Okay, good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects titled Digging Deep to Make Math Moments That Matter with Carl Pearce and with John Orr. We have a medium-sized group tonight, and I know that a few people are probably going to be joining us in a few seconds. But it's nice to see you all for the last webinar of the season. We have mostly experienced participants. I know many of your names already, and Carl and John are both technology wizards and also very experienced with OTF Connect, so it should all go very smoothly and be a lot of fun. Comme toujours, je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. We are definitely thrilled to have each and every one of you with us tonight. It's also our absolute pleasure to welcome Carl Pearce and John Orr. Carl is a mathematics consultant with the Greater Essex County School Board, where he works as a new and creative ways to spark student curiosity using online tools that are both fun and visual. He shares his work by leading professional development seminars in both mathematics and effective use of technology. Carl is also an Apple educator and trainer. John is a math teacher at the John McGregor Secondary School in the Lambton Kent District School Board. In the last few years, John has led a number of workshops and presentations on teaching pedagogy in the math classroom. He's also an Apple educator and routinely talks about implementing technology in his classroom. You can follow Carl and John on Twitter as well as on their website, and I will post the links to these websites in a few seconds. So at this point, without further ado, I'm going to invite Carl to click on his talk button and start the presentation for tonight. So Carl, feel free to join us. If you can hear me, you can click on your talk button.
There we go. Hello, everybody. Good evening. Thank you so much, Michelle, for the introduction and for helping us get our slides into Blackboard. As you had mentioned, we do like to have quite a few slides. Usually they're fully animated when we do this live in person.
A bit of a thing with the slides.
Yeah, maybe an addiction.
Pretty all the time.
Absolutely, and a bit of an addiction, but you know what? It's my little hobby. So welcome everyone. Thanks for joining us tonight. If you're from southwestern Ontario like John and I, it is hot. We are sitting in John's kitchen, which you may or may not recognize from some of his videos off of his blog. So we are sitting there, and we have the air conditioning on. It's May with the air conditioning on, so who knew? But we're really looking forward to working with you as we go deeper with Math Moments That Matter. So we're going to start it off with John here. John, what are we going to do first?
Well, we're going to play a game. It's a game that I play with my students, but what we need is we need a volunteer. And this is going to be a little bit weird because...
Kyle, sorry, I'm just jumping on. We can hear Kyle very well, but we cannot hear John as well. So John, I don't know if you could get a bit closer to your microphone. But we don't hear you well. We hear Kyle very well, but we don't hear John so well. Thanks.
Interesting. Okay, so they're saying they can't hear you. Let's do a quick little test there. Yep. Try now there, John.
Hello. Hello. No.
How are we doing?
Hello. Yep. Hello.
Yeah, let's try that. How about now?
How about now? Is that better?
Interesting. Oh, that's better, they say. Okay, I think we've figured it out.
All right, we turn the volume up.
It must be my booming voice,
I
John.
Talk deeper.
All right, here we go. So, John, what are we going to be doing?
We need a volunteer. Now, this is what we said was going to get a little bit awkward. Is since you are there but can't talk to us, we're going to ask you to type into the window. But we need one person to kind of raise their hand, or one person right now to type in that saying, "Hey, we would love to play this game." We need that one person that would love to. You got to be a little bit brave. And it's not a big game. Oh, I volunteered. Thank you, Melanie. Perfect. We have Melanie has volunteered.
All right, Melanie. Okay, John, help us out with what are the rules of this game?
Okay, so it's a simple, very simple game. There are 21 sticks in a pile. And we're going to take turns, Melanie. You go first, or I can go first. We'll talk about that in a sec. But when it's your turn and when it's my turn, we have a choice to take between 1 and 3 sticks out of this pile. So you can take 1 stick or 2 sticks or 3 sticks out of the pile. The object of the game. The winner of the game will be the person that takes the very last stick or group of sticks from this pile. Melanie, do you understand the rules? Awesome. Perfect. Okay. Would you like to go first, or would you like me to go first to demonstrate the first move? Oh, she will go first. Excellent.
Brave soul. I love it.
Kyle is going to man the board here. He's just going to click buttons to make to go from one slide to the next. But she's going to take 3 sticks out of the pile right off the bat.
Wow. Right, she wants to get that down as fast as possible. Bang. That's 3 sticks, correct?
Perfect.
The math is correct.
Okay.
Excellent.
All right. Now I'm going to take 2 sticks out of this pile. She'll take 2 also.
I like this. It's kind of scary. It's like we're playing a computer here in a way. Okay, so she's taking 2. Here we go. 2.
You know what, Melanie? I'm going to match that. 2 more.
2 more. Bang, bang. Interesting. Melanie, she's not even, like, she's like, bang. I think she's on to something here. Let's see. Okay. All right.
Yeah, what should I do? I think I'm going to take 1 stick out of this pile.
Okay. John wants to take 1. Melanie is thinking. Oh, she's just on fire here. She's taken 3 sticks. John, I'm nervous for you, buddy. I am real nervous.
Okay. I think I will take 1 stick out of this pile.
Interesting.
Oh no!
It's like,
I like that comment.
I'm so happy that you typed in. It probably sounded kind of like, oh no, because if you take 1, John, what are you going to do here, my friend?
Well, I got to take all 3 of those last ones.
And John is the winner.
Oh, thank you, Melanie. Thank you for playing. We are going to play one more time. Kyle's going to go this time. And we need 1 other volunteer to play this game. 1
other volunteer. Who wants to take me on? Now, I will say John is definitely the better of the 2 of us at this game. So I would like, hopefully you'll go easy on me. Who would like to volunteer? You can maybe just raise your hand. You can use the raise hand button, and we will select someone there. I would hate to have Michelle play us. Oh, and Dee is our first responder. Dee, do me a favor, and in the text box, just kind of say hi, just to make sure that you are accessible for that. Awesome. Dee is ready to go. What a brave soul. Dee, I am curious, would you like to go first, or would you like me to go first? Who went first last time? I think, did Melanie go?
She got first.
Melanie went first. Okay, Dee, what are you thinking? Would you like to go first, or would you like me to go first? Oh, she just gets right to it. She says, I'm taking 3. Okay, here we go. 1, 2, 3. Awesome. Dee, you've taken 3. I am going to, I want to copy you, but I'm going to maybe try something different. I'm going to take 2 sticks. How many would you like to take there? She's going for 3 again. It's like a pattern forming. 1, 2, 3. Okay. I'm going to change it out. I'm going to take 1. I'm going to take 1 stick. Dee, what would you like? She says 2. Okay. She's now changing her routine here. She says 2. I'm going to go, I think I'm going with 2. Here we go. Boom. All right. Let's see. What Dee says 1.
Oh, 1.
Is she throwing me off the path here? Does she know something I don't know? I'm going to take 3. I love that. That's awesome. I wish I could have heard that one. Would you like to finish this one off there, Melanie? Maybe change the rules or game? Or sorry, not Melanie, sorry, Dee.
Melanie's laughing.
You're right.
She was in the exact same position.
Yeah, it's like when it all comes crashing down on you. You know, if D takes 1 or 3, she's going to do 3, and that actually does me a nice favor because then I have less sticks to pick up off the pile, which is kind of nice. These are big sticks, so thank you so much. I'm going to give you a little round of applause there, Dee and Melanie, for playing. But here's what we want you to do. We want you to take, we'll give you about, normally in a room where you're with your colleagues, you could have a quick little table talk here. But I want you to take maybe 15 to 20 seconds to reflect on this game. And just as ideas come up, throw them right into the chat box and let us know, like, what are you thinking? Like, what matters here in this game? How does this thing work?
And think about this. Kyle and I won both times, and we're gonna throw this out there that was no accident. There's no accident why Kyle and I why we won. So we want you to think about what may have contributed to that.
Awesome, great job. So Dee's saying, like, you want to get to 4. Interesting. Anyone else have anything to add?
Yeah, take another minute. Think about it. Type a couple things in there.
Oh, Melanie says, we never took 3. Interesting. Okay, we're going to let that one simmer and see if anybody else has anything else to say about that. Going last and get to 4. So 4 is seemingly important here. And then I'm hearing going last. Interesting. Maybe going second is key. Interesting. You have to be facilitated. Yeah, absolutely. We definitely try to slant the tables in our direction. That's for sure.
Right.
Doing your thing.
Okay, so a couple of you said that getting to 4 was an important point, and being 4 is very important. Like everyone said when it got to 4, there was crap, or the game's over. We all knew that. You could see that at 4. So let's imagine this. If you can get to 4, the game is over. You've won. Like if you've left 4 for your opponent to choose from, then you won. So now think of this like this. It's a new game. Now the game is to get to 4. So if the game now is to get to 4, who can get to 4 first, you've won. So what number do we want to have happen? Like, what do you want to leave with your partner so that no matter what, you could then get to 4? What would that next number be? Share that out in the chat. If I can get to 7, if I leave my partner with 7, then they could get to 4 and leave me with 4, and then I'm stuck. So I think if I could leave with 8, if I could leave my partner with 8, then no matter what they pick, because they're going to pick 1, 2, or 3 sticks out of that pile, I can then automatically get to 4 from there and win. So now, if I can get to 8, I won. So scrap that game. We got a new game. It's who can get to 8 first. And then if I can leave my partner with 8, I won. So what number do I want to have or leave for that person so that I can guarantee to get to 8? There's a whole bunch of 12s are flying in. Someone said multiples of 4, and that's right. Like if I can leave 12, then I can get to 8. And then what's the next number after that? Somebody said multiple of 4, and I think you've hit it there. The next number is 16, and then the next number is 20. And there was only 21 sticks in this pile to begin with. So, when I think Melanie went first when I played, and she took, I think, 3 sticks to begin this game, I was a little bit worried because if she went first and chose 1 stick, then she's at 20, and that's the winning position, and it had me a little bit worried. But basically, if whoever goes first and knows the winning strategy, they're guaranteed to win this game because they can get to 20. And if they can get to 20, they can get to all the other multiples of 4, and you won the game off the first move. So that's a game I play with my students quite regularly. And sometimes, yeah, I'm going to play again. And sometimes what I do is I put money down on the table. It's like, all right, who can, if you want to play me in this game, if anyone beats me in this game, I will give you this $10 bill that's in my pocket. And the kids are just throwing their hands up to play this game, and knowing that they cannot win if I go first, and if they don't know the strategy. So that's always a fun time. But why we bring this up to begin the workshop here tonight is that when I play this game with my students, it always brings me back to remembering my experience as a student in school. You see, when you play this game, if you know the winning strategy, you can win every time. But if you don't know the winning strategy, you're playing this game as if you're blind. You're making moves, like Dee and Melanie were making moves that they didn't see the outcome in the end. They were choosing numbers, they were hoping for best case scenario to come out in the end. And you know, that reminded me as a kid that took math class, mostly because I was great at following the rules. Like, I could follow rules of the game, and I was making moves by following the rules in math class. And I was hoping for a great outcome in the end. And you know, for me, I had a lot of success following rules. Like, you're looking at my grade 4 exercise book for math class. My mom pulled this out of the archives a couple months ago, and she gave it to me. And you notice I had a lot of success following those rules about multiplying them, and it even awarded me a sticker. Like, look at that sticker. Like, that sticker is not just a normal sticker. That sticker is like a puppy sticker. Like the sticker that when you close the book, it doesn't close all the way. It's off the page a little bit. Like, you guys know what sticker that is. Like, that was my Master Multiplier award. And I was following the rules of the game of math class to earn that sticker. But, you know, later on when I was pushed to demonstrate my learning in a different way, I realized some of the wheels fell off. And this was my actual grade 4 math test that my mom also pulled out of the woodwork here. And you can see that when I'm pushed to explain my thinking, it didn't go so well. And yes, that is the actual comment that my teacher left when I was in grade 4. Isn't that hilarious?
Yeah, I like to call that's Growing Success 101, right there. So that was the introduction of descriptive feedback early on.
Yikes. So we bring this up because, you know, like we follow the game so much, and for me this was a huge moment. Like, it still sticks in my memory as something to remember about math class. And I thought I was a great math student. I had the Master Multiplier award, but then, you know, I was pushed and I failed to show that thinking, and it stuck in my memory as something that's very memorable. And I know Kyle has a similar memory about his experience. And why we're bringing this up is because this workshop is about creating memorable math moments for our students. I'm going to let Kyle share his moment first, and then we're going to come back and talk about how we can create memorable moments for our students.
Yeah, so for me, you know, I look at John's work here, and you know, at least he got to start with a happy story. And for myself, mine isn't from K to 12, but it's actually from my post-secondary experience. And I was going to the University of Windsor and trying to get my mathematics degree in second year when a professor asked me to meet him in his office during office hours. And he looked me in the eyes and said, "You don't know anything about math." And, you know, for a student who at least believed to know math, based on how well I did through K to 12, I was getting, you know, reasonably decent marks. But unfortunately, I wasn't able to translate that into any sort of conceptual understanding later on. So for me, that was a serious sort of wake-up call for me. But unfortunately, it never really dawned on me until I began teaching math that professor actually was 100% correct. I did not understand the mathematics that I was actually doing. I was able to follow steps and procedures, but I wasn't able to actually understand the math. So tonight what we want to do is we want to find some interesting ways that we can do that and help spark curiosity in our students so that we can help them fuel sense making. So we want to give you just a moment here to actually do a bit of a brainstorm, and we're going to just share it out loud. And normally we would let you do this. We would let you do this in a group before sharing, but just into the chat pod, even if we just get a few people out there, just to share a memorable math moment from their education experience. It could be K to post-secondary. You know, it could be positive. Maybe it wasn't so positive. We'll give you guys about 60 seconds to do that just in the chat pod here, and we'll comment on those as they come. Well, there's one from Melanie. Unfortunately, you know, the messaging there definitely not promoting a growth mindset. That's for sure. You know, so glad to see that that you definitely overcame that, and here you are teaching here in Ontario, one of the leaders in education. And Caroline kind of hitting that wall. We like to say, John mentioned earlier about the wheels falling off, and for some students, the wheels fall off in second year university like they did for me. It sounds like for you, it might have been grade 12 in calculus. For some other students, it's before they even get into our schooling system because they just don't have the prior knowledge in order to be at the same level as some of the other students in their classroom, and unfortunately they get left behind. So it just happens at different times, unfortunately. That's great. Great to hear there, Mr. Robertridge, it looks like. So, you know, in college, being able to actually have someone encourage you to keep going and keep persevering. Excellent. So what we want to do today is we want to take some time. And I want to mention as well, like when we think about these memorable math moments that you shared in the chat box, you know, if you think about that, you know, what are those math moments you want to matter for your students? I noticed that in the chat box, none of you said, you know, I really want them to know how to find a derivative from calculus class, or if you're teaching in elementary, I want them to know, you know, how to write an equation of a line. You know, these aren't things that we're really hoping will resonate with our students. Like, we want something more.
Yeah, like we're remembering these moments, but if you could pick one thing, you could pick one thing that you want your students in your class to remember 5 years from now, what would that one thing be? So one thing that you'd want your students to remember 5 years from now about math class, what would that one thing be? Write that down in the chat box there. We'll take a couple. We'll give you, this might take a minute to think about, so we're going to give you a minute. We'll come back in a sec.
All right, we see lots coming in, so anyone can do math. You don't have to be special. That's great. The fake math gene that some people believe I am either a math person or I'm not. You want them to remember how fun the class was. And oh, there you go. Sorry, I think I said Mr., but sorry, Ann. Thank you for sharing. You might not get it right away, but if you persevere, work hard, you can. Awesome.
I saw somebody that say the math was everywhere, and that's something that, you know, I always want my students to remember too, that sometimes the content itself is secondary, and that there's bigger ideas. There's a problem worthy of their time has multiple solution paths, so that they shouldn't be looking for one answer. This is a big thing I'm trying to push with my students too. I wish that my students remember this also.
And we're going to be talking a little bit later about how important it is that we're not looking for one answer or one solution strategy. So that's going to be something big. Mistakes mean growth is coming in from Marnie.
It's funny that these are things that I never, coming out of school, remembered about math. I always thought math was the content. And as a teacher, these are the things I want my students to remember too.
And How to Persevere, shared by Christina. So we're seeing a lot of these ideas coming in, and again, we're not seeing people saying, like, I want you to remember the quadratic formula. Like the quadratic formula is really useful for certain purposes, but that's not necessarily the thing that we want them to remember about math class. We want them to be able to access that tool when they need it, but not necessarily that they know it on the back of their hand.
Right, and this is interesting that we're saying these things that we want our students to remember, and we're all in agreement here, I'm pretty sure. But when we think back to what they actually said, like what you remembered as a student, these are not lining up, right? Like they're not like what you remember as a student, what you want them to remember as a student are not lining up. And we want to propose that what if they did remember all these things? What if they did remember to persevere? What if they did remember that math was everywhere, or that we valued multiple solutions or not just one? Like, what happens if they remembered how to be resilient problem solvers, or they remembered a lesson on rates of change that you did and you put a lot of work into it to create this moment for them? Like, what if they remember these things years later and it meant something to them? What if they remembered everything about math class and that was positive? So much of memory in our society is negative about math class, but what if we could change that? What if those memories were all positive?
So tonight what we're going to do, John and I have spent a lot of time here. Usually this would be an animated slide of videos playing, but you can get the idea from the still screenshot. We've spent a lot of time trying to find ways to pique curiosity and spark curiosity in our students. But only recently did we realize that, sparking curiosity alone isn't going to help students do those things that we all listed in the chat box just now. So what we want to do is take you through 3 big ideas that we believe are important to make math moments that matter. And we're going to be listing all 3 a little later tonight. We're going to start with the first one tonight, which is important. It is called Sparking Curiosity. And the reason we believe this one is so important as the beginning is because without it, you don't have an audience paying attention to what you want to teach them or what you're hoping that they'll understand in math class. So what we're going to do is take a couple minutes here before we dive into a task to really talk about, like, what do we mean by sparking curiosity? And we're going to give you a couple little examples prior to us diving into a full-blown task where we're going to ask you to be the students and participate in our online webinar classroom. So the first one is trying to find some elements of curiosity, and we're going to do this through this particular problem here, and John's going to take us through that.
Like some people say, like, you have to engage our students, and we want them to be curious. And sometimes we say, in order to make our problems meaningful to our students, they should be real life. We should put some context into this. We shouldn't be just doing X's and Y's kind of problems. And, that's a true statement. But, for example, this question right here is a real-world problem about supply and demand. But, I'm going to argue that this is not more interesting than doing any sort of X's and Y kind of problem. I definitely want my students to be able to solve problems like this, but this is not begging them, getting them to beg to solve this answer. No one's really wanting to know when these, demand equals the supply. So what we want to argue is this is not just because it's real world does not necessarily make it curious. We can take this same skill about solving systems of equations and we can strip it of the context and still make this more curious. So here's what we want you to do. Normally this slide would play for you, but because of the online atmosphere we have here, we want you to go to this link right here. And it's going to allow you to play a video. It's a very short video, but you'll get a sense, and I'll start talking. As soon as, about 30 seconds are up, I'll talk about this video.
Hang on. All right, it should be there. Try a refresh right now. We just tested the link as well, and it gave us a problem, but it is good now. So Jan and Caroline, do us a favor. Try clicking that link again, maybe refreshing your browser. It's my apology. Oh, there we go. I think it says it is good. There we go. D is on board. All right, we're going to give you a moment to try that. Our bad. So as you're watching this video here, there is no sound to be had, but we want you thinking about that last problem, and we're talking about supply and demand, and talking about this real-world problem that's supposed to engage me as a student because it's relevant. Yet, what you're seeing in front of you is just a different way to strip apart all of that context in that particular case, and to get students noticing and wondering.
Right, like when you were watching that video, this is the same context, or not the same context, but the same skill before. What the big question we're asking them to wonder here is, like, where do those dots meet up? Like, you're not seeing exactly where they meet up, but where will they meet up? That's the same situation, the same skill as the supply and demand problem. We're going to do the exact same math to solve this problem as we did there, but what we're doing is we're asking students to predict. You'll notice that the purple dot was moving. We can have it move so that it's like, do they line up here? Is this where we would predict it to line up? Like, this is what makes it curious. Stripping it away is helpful. It's not the context. It's getting kids to think about and make predictions. That's one way we can be more curious than just putting context in.
So this next problem I'm going to take you through here is, I'm calling it candle burning. And it is, a typical textbook problem. We've got a candle. Everybody's lit a candle before.
I have a candle.
Hey, I've got candles. I've got candles. We've all had birthdays. We've all had candles on the birthday cake. So this must be relevant. It must be interesting to students. Yet, however, the scenario is not actually begging me to solve it. Like, I'm looking at this problem and I'm thinking, you know what? I'm not really curious to find out the answer to this problem. So we're going to have you do the same thing again. This time the link's going to work, and I promise you that. But we're going to have you kind of look at it a different way, and we're going to strip that away, and we're going to have you hit this link here, which is coming to the chat box from Michelle. There it is right there. We'll have you click on that and let you watch that. Again, just ambient noise in the background. Everything in this particular video is essentially from that particular problem, except we've, again, stripped it away. And you'll notice it doesn't make it any more relevant to my life, but there's something there. There's something about it that just draws me in. So we'll give you a moment to watch that video. And go ahead and just, in the chat box, if you'd like to share with us, like, what do you notice, what do you wonder about that particular video as it's playing? Awesome. So we've got, does it burn at a linear rate? Where did all the wax go? Is it a waxless candle? Couldn't be a dollar store candle because those candles are really, really messy. How long is it actually going to take? So you can probably notice that we're cutting out parts of the clip. Does it burn straight through, or was it altered along the way? So there's tons of things we can ask about this problem. And there's really, there's no reason why I should want to know the answer to any of these problems, but something is drawing me in. We want to touch on those ideas today.
And then another problem, one very, very common problem we have in our grade 9 class, and it stretches in lower grades and higher grades too, is maximizing area. And when we have this problem, like this is about Maya and edging a rectangular flower bed, but we'd want to make this, to make this more curious, a lot of us want to change the problem. Like you'd say, hey, let's change Maya. Let's not put Maya. Let's put our kid's name in, like Toby, or let's put another name in, like me. I mean, like, we'll put me in, and people will be engaged. So, like, hey, look at my name's in there. Like, that's fun, right? Like, we're gonna do math now, or maybe we'll do this. Like, no one really has a flower bed. They don't do that. So we'll change that. We'll make it about what's next there? We'll make it about a pig pen. Like, oh, a pig pen. Oh, gee, like, no, that doesn't make sense. And then a cell phone. Oh, kids love cell phones. We'll make it about a cell phone. But it doesn't even make sense to change this problem. Like, like we do this all the time where we manipulate problems just so kids will find it interesting. But again, what are the elements that make things curious? And, you know, one thing that makes everything curious is mystery. Like, let's create some mystery. Go ahead and click this link. It's going to pop up right there for snippet 3. Watch that one and share out in the message box what you notice. You know, if you're watching this now, you're kind of like, what is this? These lines are moving on the screen. Like, what's going on right here? And this is the same problem that the maximizing has. But, you know, my students, when they see this, they're like, what's going on? Like, I'm interested in this. This has a mystery to this. Like, I'm seeing rectangles, and those rectangles are changing, but, you know, the sidelines aren't changing. Not the exact same thing. Melanie says, how many of the shapes have the same area? That's a great question that we could explore. Like, the perimeter stays the same, but the area changes, Anik said. So, like, you're driving the question. Like, students drive these questions, and I don't have to present that question to them. That mystery adds to that. So we're arguing here that it doesn't have to be context. It doesn't have to be about, you know, putting kids' names in. It doesn't even have to be about video. It just has to be about, you know, sparking curiosity, and a lot of that means withholding information. Like, don't give them all that information up front. Hold it back.
And the last one we're going to share with you is a typical grade 9 problem. Again, we really try to pick something that's going to appeal a little bit to both sides, both panels here. This one's a distance time problem here, where we're talking about somebody walking. You know, you realize that, oh, there's something in their shoe, he's got to stop after a certain amount of time and a certain distance. So what does that distance time graph actually look like? Like, it's me. Like, the person's name's Kyle, so it must be relevant, it must be interesting. So again, this last little video, we're going to have you do a quick notice and wonder for it. That video link is coming to the chat box right now. It's the last one to watch. And what are you thinking if you're the student? What do you notice? What do you wonder? And then we're going to be diving into some of these elements through a full-blown task where we're going to ask you to engage as a student. So in this particular problem, you're getting you're going to get a lot of noticing, a lot of wondering, and you're also giving students just an opportunity to just kind of be drawn into the problem. So what we're going to be doing today is as I mentioned, we're going to be taking you through a task. Notice, oh, there you go. So Dee watched it again. Didn't notice that there was time actually showing up the first time. And I'll be honest, when I show this the first time, I wouldn't show time at all. Like, I would just show the person walking and stopping. That's actually me in front of the district office here in Windsor. And, you know, we just let students just kind of throw ideas out there. Every student can participate in that sort of activity and that sort of discussion. And that really gets the math discourse going, and we can help funnel that into some meaningful math talk. So today what we're going to be doing is we are going to be talking about these elements, and the first one is sparking curiosity, but we're also going to really be trying to tap into our second element of making math moments that matter, which is fueling sense making. The whole purpose for why we want students engaged in our class is so that they can do some sense making with the mathematics. And we can't get them to do that if they're not engaged in the actual math. So that's what we're going to be doing. So John, tell them how we're going to proceed with this particular problem right now.
Okay, so we want you to put two hats on. One hat is you're going to be a student in our math class, and we're going to try to walk through this task, or we're going to be the teachers. You're going to be the student, but also at the same time, we want you to wear the teacher hat. Like, we want you to say, how does this work in my classroom? How can I modify this task so that it can work in my grade 3 class? Because we've had teachers do that with this task in grade 3 all the way up to grade 10. So we want you to put that hat on. We want you to think about, like, when it's time to do a little bit of work, like, how are my students going to solve this problem? We want you to think in those two hats. How would I solve this as a student? How would I use this in my classroom? So first, what you need to do is you need to grab a piece of paper or something to write with.
and then we need you to create this on your page. So we want you to write down 2 headers. You don't have to write them all. You could probably just create the 2 boxes. We want one side for what did you notice, and the other side for what did you wonder. And all you have to do is we're gonna give you another link to a clip, and we want you to watch this clip and jot down a couple things you notice and a couple things you wonder. 2 things under each heading. We want you to do that on paper, because then what we can do is once you have a minute or 2 to watch the video, because the video it kind of like a minute and a half long maybe.
Yeah,
a minute. So a minute to watch the video, and then another minute to think about noticings and wonders. And here's the thing: anything goes. Anything you notice, write it down. Anything you wonder, write that down too. And then once you put that on paper, choose 1 or 2 to put into the chat box. Go ahead.
And as you're ready, feel free to toss in your noticings and wonderings right into the chat box. I'm loving our first questions, our first wonderings from Ben. How many did we eat, and how much Pepto did you take after? It was definitely an uncomfortable situation. Notice that we both had plaid shirts on. Thanks, Jan, for that. Definitely, that is one that does come up quite often. We have a uncanny habit of wearing plaid. How many candies were there to begin with? One person eats kisses and one eats pumpkins. Does a kiss take as long to chew as a sphere? Interesting. So something about like the shape possibly influencing like the speed at which or the rate at which we're eating. How long did it take to eat each one? Very cool. Lots. Was there a center? Did you eat at the same rate? Did y'all? I like that. So Louisiana's coming in here. Did we chew the candies at the same rate? And was it a race? Like tons of things coming up here. And I'm loving all of these details you're sharing. So you've got all these noticings, all these wonderings. In class, we're going to be writing all this stuff down on the board. We're going to be ensuring that every student feels like their voice is being heard. And this is going to look a little different at the beginning of the year versus the middle of the year and the end of the year, because eventually you get to a place where it's just that culture just exists. Like we don't even have to say anything anymore. It's just what we do here. Ebony's saying couldn't figure out what the pictures were on the wall. Ironically, that video, I didn't realize this until this very moment. We are sitting in the exact spot that we were.
We are. That's the kitchen that we're in right now.
Yeah, this is where we are like hosting live from, except we're not wearing plaid. So that's an improvement. So lots of things going on here in our noticings and wonderings. John wants to take us through. He actually did this task recently in his class. And he's going to take you through some of the noticings and wonderings that came out from his grade 9 applied class.
So I had my students do the same thing you did. They jotted down on 2 sides. What did they notice? What did they wonder? Here's another one. I'm sure you guys wondered and noticed some of these things. Like, we're both wearing plaid. We just need some spelling work with plaid. The candy flies into those hands. They thought we were magicians. I wonder why he's doing this. And this is a huge, huge question. I love when this question comes out. Like, kids will say, like, what is going on? Like, what do you mean, right? Like, what do you mean I gotta watch this video? I like the why you eat chocolate, which, like, to me is, we're gonna accept every question, but that's an easy answer because chocolate rocks. That's why we're eating chocolate. And I think with Halloween around time.
Absolutely.
Great.
Stealing children's candy, it's great.
But going back to that, I wonder why he's doing this. I love that question. I put that question up on the wall. We'll do this. We'll take, after they think and they do a pair, share, we'll put them up on the wall as they get more confident in the class. And I love that question to go up on that wall, because then we can always come back to it later to say, look at why did we do this problem? Do you see now why we did it? And they answer that themselves because they now see the math that we did in here. So you'll notice this is my wall that they put up. We've said why using chocolate? There's that one. Like, why was it in reverse? How long did it take? Eric wanted to know. Kaden said, why candy? Like, why do we need something different? But notice Justin said, like, how much chocolate was there? And that's a question that popped up,
you know, it pops up every time we do this problem. And I've done this problem with different classes and you know, different groups of teachers. And someone will say, like, how many pieces of chocolate did you really eat?
And that came up here in the chat box as well. So we saw that one really early on. And sometimes, you know, like we might do a problem and maybe the question you're hoping will come up doesn't come up, and that's okay. We can try to maybe suggest different questions as well. But this one's fairly almost intuitive for students to bring up.
So here's what we want. We're gonna, like, I circled that question on the board, and we're gonna circle it right now for us. So what we want you to do is we want you to predict. We want you to predict how many chocolates I ate, how many chocolates Kyle ate. If you want to do that as a total, that would be fine. But throw those into the chat box. You could say John ate this many, Kyle ate this many, so that we can all see. What you're seeing too is the wrappers for all the chocolates we ate. We peeled them, we ate them, we put the wrappers in that pile right there. So those are all the wrappers between the two of us. And we want you to make a prediction of how many I would have eaten, how many Kyle would have eaten, and throw that in the chat box. Go ahead, please.
All right, Dee's coming out fast. I love it. Like Dee, when we were in the game early on, like she was like, boom, I'm taking 2 sticks. Boom, I'm taking 3 sticks. And right here, Dee's saying, John ate 5, Kyle ate 6. We also want to reiterate that big pile right there, that is all the wrappers from our candies. Marty's thinking 15 each. Like, you know, it would be unfair for John to eat more than me or Kyle to eat more than him because we're just really nice people like that.
Right, and as these numbers are kind of trickling in, something that we do with our students quite regularly is when we ask them to predict. You know, predicting is a huge part of being, you know, sparking that curiosity because they're buying into this. They're putting their foot in the door. They're getting into this problem. But what we do is we have them do a too high and a too low. So what I mean by that is, what number would be too low? Like, we ate more than this many each. What do you think? Like, do we eat more than 5? Do we eat more than 6? Do we eat more than 10? Like, there's a number out there that you're thinking right now, like, they must have eaten more than this. That's our too low. And what I have my students also do is they have to think about what is too high. Like, we know we didn't eat 1 million chocolates, so let's be riskier with our too high. Did we eat, you know, is it crazy that we would have eaten 60 chocolates each? Or 60 chocolates even together. These are things that we want our students to think about. And we're not going to ask you to type these in right now because we've got a lot of estimates coming in. But what we're doing is we're framing in our possible answers. We're saying it's got to be more than this, but less than this. And anything out of that as an answer we get in the end doesn't make sense. And we can always refer back to that scale we're creating out.
And it's great that you're all sharing out in the chat box because, like, just by taking a quick glance, we can sort of see like what seems reasonable and what doesn't. Like some people are thinking like, no, it's single digits. Like we didn't eat that many, and that could be totally perception or maybe it's super accurate. We're not really sure. And then we have some people that may assume higher because they're like, well, maybe we didn't see the entire video. Like what if they were eating for like triple the amount of time that we just saw? Like we don't really know, but at least we're setting ourselves up to kind of understand the context. I love like Jan here throwing like an extension question and right away, how many calories? Like a question I would love to give my kids is how many calories, but more like what I really want to know is like how many kilometers do I have to run to burn off those calories?
A lot.
Right? And yeah, John's saying a lot. Like we felt pretty horrible after this. But all kinds of great ideas coming up here. And with our students, and if you were in a live workshop with us, we would actually hand you this particular task template, not suggesting you need to have one in every class, but sometimes I know when I was first starting this process, I would like to have something to kind of almost guide me a little bit, guide my students, and then over time it just becomes so instinctual that you probably wouldn't necessarily need it, but it sort of frames some of the pieces to make sure. And there's a link down at the bottom, makemathmoments.com, and
if you went there, you can put in your email address, and you will be in an automatic email to get that exact file, plus a whole bunch of other resources we're going to share at the end. So that's something that we're handing out to you to take with you into your class. We're gonna give you a whole bunch of links that we go to get some of these resources, these lessons. There's even a lesson for the task we're doing, or a link to the task we're doing right now.
to get the video file. So you can go there later, but what we want you to do right now is, now that you've made some predictions and you've seen some of the ranges that are coming in, we are thinking what we would do next with our students is, our next step is not to just give them all the information, we want them to ask for the information. So to help narrow down your prediction, we feel like this is what math is all about, right? Like we've made these, some people said 5, some people said 25. Like, that's a huge gap. I always phrase it as, that's way too big. That's way too of a variable gap. Let's narrow that gap down. Like, what can we do to bring that gap smaller so that we're not so wide? So what else would you like to know? Like, if we have some information, we did this. We could give you some more information to help narrow this prediction down. What would you like to know?
Yeah, and I like to think of this part as like, this is where I get to like be like happy, because I get to give something, right? So you get to ask me and I get to gift you information. So rather than me just kind of like throwing it up on the board and saying, boom, go solve this, now I'm sort of letting you control things here, and I might adjust my plan as we go depending on what you ask me. So we're going to give you an opportunity in the chat box here. What do you want to know? Like, what can we do to help you? So Caroline wants to know, like, did we see all the eating? And you know what? You did. You saw. Oh, no, you didn't. John's shaking his head. He's like, Kyle, you're crazy. No, you didn't. We didn't show all the eating. So there was a little more eating. But those wrappers do represent all the wrappers of all the eating that we did do.
So we're going to give you 1 minute. Throw a couple things into the chat box there, and then we'll take up a couple of those. But and then I do want to talk about a process that I do with my students on this stage. Go ahead, chat box.
And I do want to say before I turn the mute on, Ben, yeah.
Come on.
I know, he's just jabbing left, right, and center. I love it. So now, great questions coming up. All those wrappers are there. There are no uneaten candies in that pile. But what we're wondering though is, like, what if like we could give you some detail, like more detail, not just like zoom out so you could see more of the pile. Like, we're talking like, what information could we give you? Like, if we were able to provide you with some detail, I'm wondering like what details might be important. Like, would like the weight be important to you? Like, would the smell be important to you? John thinks the smell would be fabulous, but we can't do that in a webinar. So think about that. Share out in the chat box what might we be able to give you, and it doesn't have to be from the image. Maybe we know something that you don't. Awesome. So we've got lots of things coming in. Great. We can take those and we can help students, like the time frame. Like, if we told you like exactly how long it took us, like maybe you could look at, how long it takes on average to eat one chocolate, right? Or the total weight of a single pumpkin. Great stuff.
And what is great about this step with my students is if they can articulate what they want to know more about, then you can see the beginnings of strategies. Like, for example, I think Jan said time frame. So she's imagining, like, look, if I knew the time, I could start to piece together rates. And she's got, like, you can see that she's got a strategy in mind.
Yeah, and Janice is talking about the weight of a single pumpkin and the weight of a single kiss. Like, if a student says that, like, I'm like, you're thinking about the unit weight of this candy. Like, that's like something that I can use in order to inform my teaching later in the lesson.
Right, and that's huge for problem solving. Like, we want kids to solve problems, and we usually just show them how to solve problems and not give them the opportunity to try to develop strategies on their own. And this, by withholding all this information, they're forced to think about strategies so that when all of a sudden they're getting what they want, they know how to use it. So much of the time we give them numbers and they just like, I don't know how to use these numbers. Do I put this number here? Do I just multiply these two numbers together? Do I just divide these numbers together?
how often do you have your students do that? And you're like, why did you divide? And they don't know. It's we didn't give them an opportunity to think of a strategy. So here's what we're going to do. We're going to show you this image right here. And so we're going to put 3 of the Pearce's Kisses in one measuring cup. We're going to put 3 of the pumpkins in the other measuring cup. I ate the pumpkins. Kyle ate the Hershey's Kisses. And Kyle, are you ready? You're going to strip them down. Strip them down. Boom. There they go. Okay, so
It's almost the weekend.
it is. And here's what we're going to do. We're going to put those in the microwave and now melt them. There they go.
Yikes.
Okay. So now they're melted. So here's what we want you to do. We want to encourage you to write this down because we're going to move on from this slide. Just go ahead.
And at the same time, too, I do want to let you know that we are going to be encouraging you to actually do this task, and we're hoping that you're going to be willing to use some sort of smartphone, iPad, or even just like your FaceTime camera on your Mac or your webcam to take a photo of your solution. Here comes the information from Michelle. Thanks so much. So you're going to click that link and you're going to type in the game pin, follow those instructions, and when you're done, you're going to share a solution strategy with us. So we want to be able to take those solutions and we'll actually be able to share them in the webinar. We will not identify anybody. You're more than welcome to identify yourself, but you don't have to. What we want you thinking about is how you solve the problem and thinking like you're a student, right? We want to see what a student might do in order to solve this problem with any sort of pre-teaching.
Right, and this is one piece of the problem. You know, right now we're showing you one piece. Kyle, go back one slide just a sec. So notice there's 3 of each, and now when we melt them down, we have these numbers. So we have 17 milliliters in the cup on the left, and we have 8.5 milliliters in the cup on the right. Those were those 3 melted down. You're seeing the 3. Kyle, we're going to get I think we're going to ask, we're going to get something else. Every time we've had my students, they'll say, like, now that we know this, like, now what do you want to know? And students will say, hey, I'd love to know how much.
And like Melanie, I'm like pointing at the screen and banging on it because it says, wait a second, so the person who ate the pumpkins ate twice as much as the chocolate as the person who didn't? Like, that's really interesting when students pick up on that, right?
Yeah, and that was me.
Yeah, John felt a lot worse than I did, that's for sure.
All right, so what you're saying now is the total amount of chocolate in milliliters that each of us ate. So on the last slide, you had 17 milliliters for those 3 pumpkins, and you had 8.5 milliliters for the Hershey's Kisses, the 3 of them, and you're seeing in total how much each of us ate for the pumpkins. That was me, John, and Kyle ate 55.8 milliliters in the Hershey's Kisses. So, like what Kyle said, we want you to solve this problem in as many ways as you can, but remember those 2 hats that you were wearing. One was, how is your students going to solve this? The other hat was, as a teacher, how could you modify this problem in your classroom? Where do you see this fitting in? Because as I said, we've had teachers from grade 3 through 10 use this problem in their classroom. So we want you to jot that down, but then also Kyle's provided you a link to a game show that you can jump into, and it allows you to take a picture of your work so that we can all see it. And that's what, once you're done working though, take that picture and try to put that into the game show. And the instructions are there in the chat box. So we'll give you a few minutes of that because there's a lot going on there. You got to figure out how many chocolates each of us ate with this information, and then also take a picture of that. And then maybe also think about different ways that someone might solve this problem. So I think we're gonna turn the mic off just for a few moments to give you some thinking time.
All right, we've got some solutions coming in through Knowledge Check, so I want to thank you again. I will mention that when we press end on Knowledge Hook, like Knowledge Hook has content, ready-made content that you could actually use, like questions, math questions you can use in your class. But the one feature that really drew me towards them was this upload solution feature. So all I did, I just created a question, asked you to upload a solution, and that's it. I didn't really, spent maybe 2 minutes doing it, just because I want to be able to see what you're thinking. So when I hit the end button, I just want you to know, even though it says that the question has ended, you can actually still click on the Upload Solution button. So if you're still working on your solution, keep going. It's actually a free tool as well, so definitely check out khmath.com. You can create a teacher account and try it out for yourself. But right now, what I think we're going to do is start going through some of what you did so that we can actually go through some of our consolidation as we go here.
All right, so let's end that and have a peek.
So here we are on our screen. You can't see it yet, but on my side, I just hit the rotate button because it came in sideways, but that's no problem. I'm just going to take that and, oh, that didn't work like it usually does. So I'm hoping, here's what I'm going to do. We're going to save that image to my desktop, and I am hoping that will work for me. I believe it will. There it is. So here's our first solution here.
Hang on.
Hopefully, bam, there it is. So excellent, it worked, and we see it looks like we've set up a proportion of equivalent ratios or equivalent rates, and we end up with approximately 20. It looks like 20 each. So there's one solution for us. I'm going to move that to the side here, and we're going to grab another one that came in. Here is another that I am going to grab as well. There it is. And oops, you did not work. Let's try now. Whoops. Oh, I don't know if Michelle can help us on the fly here, but can you delete old slides that we've already gone past? Because I think we've hit the limit of what we can put in. So what I might do is maybe I'll delete this last image, and maybe we'll be able to put in another. No, eh? Yeah, conference has exceeded. So that's a new warning for us.
Yeah, you remember, Cal, I told you I had to delete some of my slides because...
share, but oh, darn. Okay, so here we go. I guess we'll do application sharing here. All right, so I'm going to share. Let's go ahead and we'll share my Google Chrome. Hopefully that'll work here.
Here it comes.
Here it is. There it is. It's coming. So there's another solution. Now you get to actually see the Knowledge Hook, the actual Knowledge Hook dashboard that the teachers get to see. Down at the bottom, you'll see there's like a little rotate button there. It might be a little delayed on your side, but there is a rotate button. Here we see someone using a strategy. It looks like they've found a unit rate and multiplied. So awesome. So using like a unit rate strategy here. So if I know that 17 milliliters and there's we have 3 of those chocolates, then I could divide by 3 to figure out how many per each. And I'm going to have to make it a little bit of an assumption how you got to the total, but I would definitely have that conversation with you in the classroom if that was a student. Let's have a look at another one here. John, what are you seeing on the screen now?
Interesting. I'm seeing 3 and 3, and then I'm seeing the 5.6 pop up again, the 2.8 pop up again. We're seeing that same kind of division to get the unit rates. We're seeing 5.6 per chocolate.
And then over here, 2.8 per chocolate.
All right, and then I'm not seeing a final, oh, there's a 20, way up there.
20 way up there, awesome.
Interesting.
So one thing that I like to mention when we lead teacher workshops is when we look at teachers' solutions and when we look at their thinking, oftentimes it looks fairly organized like what our students would do. And I remember there was a moment or a time in my career where I would be talking to my students and saying that they need to actually show me their thinking a little better, and I would actually sort of almost rant on them a little bit. I'm hoping I can end this application sharing somehow, and it is not allowing me to. So I'm going to do that right here.
You go to Tools, Application Sharing, and then stop application sharing, and then you click on the little squiggy to go back to the slides.
Yeah, let's see. How do I get back to the slides now? Oh, maybe it's right here.
So Kyle, you go to Tools, Application Sharing, Stop Sharing.
Oh, here we are. There we are. Excellent. We're good to go. Awesome.
Yeah,
Sorry about that. Okay. It's been a while since I had to do application sharing. Awesome. And now we will go back to the slides. Beautiful. Sorry about that, friends. But yeah, so like as I look at teacher solutions, oftentimes the organization looks exactly like our students, where it seems disorganized, but it's actually, that's what brainstorming is. Like, that's what we need students to be doing. We need them to feel comfortable jotting things down as they think about it and not worrying so much about the presentation. We can worry about that later. So what we're going to be doing now is we're going to be diving in and really like talking about this question a little bit as if it was coming out of a textbook. So we gave you some snippets earlier of different questions and how to make them more curious. Here, we're looking at the same problem that's given as a word problem. We're not hitting, like, we're not trying to like bash word problems. We're definitely going to continue using word problems, but we're just thinking like whenever we want to make math moments that matter to our students, we want to make sure that we give them something that they'll remember. And this particular problem in this form is not going to be very memorable, but what you just saw may be. And we're not going to have them go to the back of the book to find this solution. We're actually going to, you know, try to give them something that's a little bit more memorable. And when we do that, when we go ahead and do that, which is going to be right on this slide here, we're going to have you type in or click on this link in order to see the last portion of this task, to see how close you came to determining how many chocolates John and I both ate, and then we'll come back together in about 1 minute's time.
Now as you watch it, you might be watching it right now, you might have clicked that fast, but we want you to think, like, when I have my students watch these consolidation videos of like what the right answer is, like flipping to the back of the book, I have them, we always want to think like, what if you've calculated 20, everyone calculate, like the people in the workshop calculated 20, the question is it going to be 20? Is it 20 the right answer? Is it going to be less than 20? Is it going to be more than 20? What is that appropriate answer? Is math right here today? So we always want to talk about that, and what we're doing is really doing part F of every textbook problem that's there. It's like, what assumptions did we make? We assumed that all the chocolates were the same. We assumed that it was exactly 17 milliliters. We assumed that Kyle, he didn't quit halfway through. So we always like to talk about those. That's a huge part to talk about that I used to skip when I used to just teach textbook problems. You're like, well, let's not do these. Let's just do the math part. These are, really important discussion kind of problems that we can have. So we'll let you finish watching this. Let's see, is it 20? Did we both eat 20? Have a quick look and a laugh. All right, so if you're watching this, you just watched us, like you saw Kyle, he had to take a nap after this, and I had to take my glasses off, and I got so
Like we ate a lot of chocolates. We did eat 20 chocolates each. So the math worked out there. We matched the back of the book this time, and something that we probably never will do again. But now, now this is a great moment. Is the kids just watch this, and now they get to go. We get to go back to the wall that I wrote all those wonderings and noticings up, and we get to go to that kid that said, "Why did we do this?" And I go right back to them and say, "Why did we do this?" And they can tell me. They say, "Look, I guess you created this. You ate all those chocolates so that we could do a math problem." And you're right. We engaged you to want to do the math problem. You did the math problem. You struggled through it. We didn't tell you how to do it. We looked at different solutions and we compared them. And now we can also in a great spot to connect it to past ideas. And I think Kyle's going to jump into a little bit of that, and which is where we are. Like we wanted to spark curiosity so that we can fuel sense making. That's a huge part of making our math moments that matter.
Yeah, John and I both, we were lucky to have come into this idea at the same time. We both sort of ran into Dan Meyer at our OAME conference at around the same time. So we were at the same place where we were sparking curiosity with our students. We were doing a great job with it as well. Kids were into it. But the part that we really missed until only recently, maybe 3 or 4 years ago, we started realizing that the whole point of sparking curiosity is to fuel sense making. And what I want to do is take some time now, like you'll notice, like I know we didn't need to pre-teach you anything because you folks are teachers, so you've got the tools in your tool belt. But with our students, we would give them strategies, allow them to use their own strategies in order to solve this particular problem. And then we go around and we try to figure out where do we go in our consolidation. And for some students, like that might be like needing concrete manipulatives, right? Like we might start there. Maybe we actually use the actual chocolate in order to do some of this work. So like for example here, like we know that with 3 pumpkins of 17 milliliters for those pumpkins, like I could look at these cups and I could use like an additive strategy to just keep adding cups of 3 or cups of 17 milliliters. And you'll notice that, like, if I do 7 cups, I'm at 21 pumpkins, and I'm actually above how many milliliters I need. So I'm going to actually have to back off a little bit. But you'll notice if I take a cup away, now I'm at 18 pumpkins, and I have less of our volume there. So that's a problem. Like, I'm going to have to do a little thinking. And then over on the right, we can do a similar strategy, like an additive strategy to get us to a place where we're getting close. Like now I'm at 24 Hershey Kisses. Well, that's too many. I got to back off a little bit. Got to back off a little more. Oh, darn. Now I have less volume than I need. I need 55 and change. So what we're going to have to do is like maybe kids are ready to think fractionally. And like I could take those 17 milliliter drops. I've got 17 of them. And I could try to fair share them. And I could do the same thing with my 8.5 milliliter drops, and I could fair share those amongst 3 chocolates. And when I do that, we then are like left in a situation where, oh darn, this doesn't fair share equally. Like so now I can think fractionally. Like I'm sure most of you weren't really thinking about that with this problem. You're going, you know what, I could solve this problem. I just like divide and multiply and do all these great things that you and I can do. But for a lot of students, maybe they're not ready for that. Like this might be a great opportunity to talk about fractions. So I like chop up the leftover chunks, the leftover drops of chocolate, and I spread them out and I see, oh darn, like, I've actually got, it looks like 5 and 2 1/3 milliliters per pumpkin. And over here on the right, I've got, oh wait a second, I've got 2 milliliters plus 2/3 and a 1/6. Oh darn, what am I going to do with that? Students are going to have to do some thinking about that as well. So just depending on where your students are in their learning journey, you might approach the consolidation for this task a little differently. Something else we might consider doing is taking, and I'm just showing you sort of how a student might come to that solution afterwards. We're going to skip over some of John's students' work here. You'll see a lot of the work they're doing is additive here, but we're going to jump straight to some other representations. Like here's another representation. I'm going to back off for a second and say, if I look at an array, which is something we introduced to students back in grade 3, I can use arrays to help me with proportional reasoning. Like here I'm looking at one array, and I'm looking at the pumpkins, and I'm thinking, well, like for every 3 pumpkins, right, I can add these cups. So I've got 6 and change cups of 3 pumpkins. You can see the cups along the top. I could do the same thing for my volume. So while I could talk about this in 2 different ways, really when I'm dealing proportionally, all I'm doing is changing my units. I have 3 pumpkins, and now I have 17 milliliters, but you'll notice that the model actually looks exactly the same. So that I like to call a double array model because that array can be really powerful in some of our proportional reasoning. And you'll notice if I look at that double array, like what's sitting right in front of us is a proportion. I can set up this proportion in a couple different ways. I could set it up as like 17 over 3 is equal to 111.52 over 20, or I could set it up in any other number of ways in order to work that through. But really what I want students to do is to know and understand proportional reasoning, not necessarily know how to solve a proportion. Here we have like an area model to represent the same thing. So students might be able to actually, avoid having to draw it out, and they can just use area in order to represent that particular array. The last little model or visual model that we'll use is a double number line, and you'll notice a lot of the same numbers pop out of it. If I look at this, I can see milliliters along the top, I see pumpkins along the bottom, and students can again still use additive thinking in order to get them pretty close to the solution, and then eventually they'll be ready to start thinking multiplicatively. So if I think about that, I go, well, like how many times bigger is 111 than 17? And how many times bigger is X than 3? And we could do that by thinking about opposite operations. If I take how many milliliters total divided by the 17 milliliters, I see that there are 6.56 times bigger. Like that's how many groups of 17 there are in 111.6. And that's something that's really important for our students to understand and conceptualize. So they can't really do this by rushing to an algorithm. They really need to work with concrete and visual representations. You'll see some of John's student work here. A lot of students trying to work symbolically, but maybe if they have some other models to work with, they might be able to access the math a little bit easier. John's going to tell us about his recent consolidation here in his grade 9 class.
Yeah, like if you move, Kyle showed, how to, summarizing some strategies for proportions, but when I did this problem, I wanted to use it for linear relations. As you move up, this is where we could see it using in a grade 3, 4, 5 class, but you could also use a grade 9, 10 class. And here's how I did this with, we had this proportion which can be turned into a linear relation, like a direct variation linear relation problem. And we used it here to show rates of change and how to build equations and how to solve those equations. So we consolidated this way. We talked about different strategies, and then we went back and tried, I gave them another scenario, and we tried that other scenario using these strategies. We switched the scenario to not be about chocolates, to be about something else. And then we would go back to the walls, and by the walls I mean by, we do a lot of our works on our whiteboards around the room. So they go back and they try the strategies that we just took up, like my strategy, or maybe they did the proportion strategy that Kyle just outlined, but they would go back to the wall to work on a separate problem that's similar, but using the learning goal that we outlined in that class today. And when you have your teacher hat on, you were thinking, how does this work in my classroom? Like, we're all going to have different learning goals for these problems, and the one that you're going to point out for that day is the one you might want to focus on, and that's the one you want to practice next. And that's to create these moments. Like, you create a moment that kids are going to remember. Like, they're going to remember this chocolate thing for a long time. Kids are going to walk away knowing how many chocolates we ate. But they're going to tie this to the math that we consolidated with. And what was the learning goal that came out of this today? And where do we go next with that? In terms of that, that involves a lot of practice in that, because I want my kids to practice the crap out of activities once we know them. Like, we want to bring these strategies to the forefront, but then we want to get really good at it. And sometimes we forget that. Like, when teachers see, I'm going to do this task with a video or task where it's like a real life scenario, we think, oh, that's it, we're going to do that and move on. But no, we got to really practice the skills we want our students to do still. Like, we don't want to forget about that part of our lesson. That's what we would be doing next.
Excellent. And normally what we would be doing, we're running short on time here. I think we got really excited tonight, and we really got in depth in some of the areas. But really, like, I heard in the chat box, and I'm sorry that I can't remember who mentioned it. I want to say it might have been Dee, maybe it was, yeah, I can't remember who it was, maybe Janice. But, you know, somebody noticed that there's actually like double the amount of chocolate in one of those spheres than in one of those Hershey's Kisses, which is pretty close to a cone. And normally what we would do is have students explore that next. It might not be the same day, as you see we're running out of time here, but we'd come back to this context and we give them an opportunity to really take this context and again, sort of drive home how memorable this moment could be for students by coming back to it in a different way. So we'd give them some measurements, we'd have them do some exploration, and then we might have them try to derive what the volume formula is for a sphere, knowing that they know the volume formula for, say, a cone. And normally we would set you up nicely to actually do some of this activity. We'd have you watch a couple videos. They will be shared out by Michelle. We're not going to do them today, but I will say that all three of these video links, especially this last video link that's up on the screen right now, the volume of a sphere link, definitely give them a look, because with this particular scenario, you'll actually uncover a formula that for years I just gave to my students. I never actually helped them conceptualize where it came from, and the reality was because I didn't know where it came from. I just gave it to them because it worked. So we're going to have you do that on your own time, and we just want to take a couple minutes here. We only have 2 minutes now left to tie some loose ends. So we're going to go ahead and do some of that with you right now. So I'm just going to jump a couple slides here to help us move along. So here we are. So we wanted to talk a little bit about some of the elements for sparking curiosity. All right, so here we go. So all right, so here we go. So when we look at these 3 strategies to make math moments that matter, the first thing that we did tonight was we actually looked at sparking curiosity, and in particular, some of the elements that we want to share with you. We're not going to uncover all of them, but we do want to share a few of them with you tonight, and they are the following. Some of the ones that we really like are the following in this bubble, and a few you saw was like anticipation. You'll notice we use notice and wonder as a way to help students sort of anticipate what was going to come, what was coming next. And we also focused on withholding that information. So those are some of the ones that we used, and we really tried to help students. We want to value student voice, and we want to lower that math dial. So normally in a full day workshop, we would spend a lot of time coming and really helping you connect with each and every one of these for sparking curiosity. But the second piece is feeling sense making. We want to make sure that all the students in our class are seeing the math. They understand the concrete and the visual representations. They're using multiple representations in order to represent the mathematics and manipulatives to help them along their journey and making connections to the world around them. So these are some of the pieces that really help us to make math moments that matter. And finally, we want to be assessing students always in order to ignite their next moves. So we want to make sure that we're constantly looking at what students know and what they need to know moving forward in order to plan forward. So while we're running out of a little bit of time, we're hoping to do a little more consolidation here. We do want you to know that we will be providing resources up on our makemathmoments.com website. And I'm going to share that with you right now. There it is. If you go to that site, you'll be able to download all of our resources from tonight, including this particular task, as well as our contact information. So if we can be of any help along the way, we would love to help you along your learning journey. So on behalf of John and I want to say thank you so much for joining us, and I hope that we'll see you next year in a upcoming OTF Connect session.
Thanks so much. We will catch you on the flip side.
Can you guys hear me? Yes, hopefully yes. I must say, sorry, I was copying some emails addresses, but please, if any of you have not been registered for tonight's session, please send me an email. I put my email address. It's michelbartman@gmail.com. I'm going to type it quickly, and because I may not have the time to copy them all now, but if you send it to me, I'll make sure that I'll send you everything. And thank you so much, Kyle and John, for keeping the best session for the end. That was really my favorite session of the season. I really loved it. The two of you worked so well together. I absolutely loved the entry game that you played with Dee and with Melanie. I think that was the best part of the evening, actually. You should definitely do that more often. It was really, really thrilling. And it's funny because I'm totally useless at math, I must admit, and most people tend to be afraid of math, I guess, because of painful past memories. But I always find your math sessions to be really the most fun of our OTF Connect program, and I certainly love to work with you guys. And it's quite obvious that teachers, like students, also love to play math games online, and with the use of Knowledge Hook and application sharing, and it was really fantastic use of technology and exactly what we try to achieve in our OTF Connect session. So thank you both for being so creative and so resourceful. And I also want to thank all of you for being such incredibly motivated participants and for joining us over OTF Connect tonight. So just give me another few minutes. We don't have, that's the last session of the year, so we don't have of the year, should I say, of the season, of the school year. So we don't have any other session to advertise tonight with you guys, but I just want to let you know that we're going to have a new OTF Connect program starting next September. Since there's an election in a few days and we've heard of possible cuts, we are all crossing fingers and hoping that we'll get funding from the ministry for our next seasons, but otherwise, we will still have the program. It may not be quite as rich as in the last few years, but we will still have an OTF program session in September. So please go to the OTF website, and mid-September we will have posted all the new program for the fall season. Also want to tell you about an opportunity provided by OTF and the Ministry of Education. If you're a qualified teacher and you have completed a qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy, and I'm going to paste the link in the chat box if you want to apply for that $450 subsidy. I also want to remind you that we love your feedback. When quitting Blackboard, you will be redirected to a feedback questionnaire. It takes just a few seconds to fill it up. That would be great if you can do it tonight. And if not, we will send you a link to do it tomorrow. After the questionnaire, you will be redirected to a certificate of participation. You can just write your name, enter your name, and you'll get a certificate of participation that you can add to your learning resume. So that's it for the last session of the season. It was a really fantastic session. Please feel free to remain online if you wish to ask Carl and John a few additional questions after the recording is ended. Otherwise, I wish you all a very, very good evening and a well-deserved summer break. Thank you all once again for your participation in tonight's session, and I certainly look forward to seeing you again over OTF Connects next season. Bonne fin de soirée à tous et à toutes. Je vous souhaite de très bonnes vacances et à la saison prochaine. Merci.